Good morning, concept students. Today we are moving on to our last little chunk of information that we're going to cover, which is in chapter 7. It's solving systems of equations, meaning a system means two or more equations. So when we do this, there are three different methods we're going to explore. We're going to explore graphing today. We're going to explore substitution on our next meeting, which will be on Friday, and then we will explore elimination. And so those methods you are going to use as you move on into geometry and then as you move into advanced algebra possibly in the future as well. So we're going to go over graphing today. So I'm going to try and do this. I have my whiteboard here, but I also have this mini little whiteboard that I'm going to probably have to put the graphs on so that you can see those. So we'll see how that goes. All right, so we're going to start with the graphing method. Now, let me turn this here so that we can see. Okay, so when we do graphing, we're going to look for an equation that has two variables. So in our case, graphing is x and y. And we're going to look at where those graphs, those two equations intersect when we graph those lines. So our first system is going to be x minus y equals 3 and 2x plus 3y equals 6. Now, you'll remember when we graph lines, they have to be in slope-intercept form. So slope-intercept form is our y equals mx plus b form, where the y is all by itself. So if I look at my first equation, I have to fix this one so that y is by itself. So to give myself some room, I'm actually going to move this one and I'll move it over to the other side just so that I can solve for y. Okay, so how am I going to do that? I'm going to subtract my x over to the other side so that I get negative y equals negative x plus 3. And then I divide by negative 1. And when I do that, I get y equals x minus 3. And this is my first line. I'm also going to put a little 1 in front of the x. Okay? Now my second equation, I'm going to do the same thing. So I'm going to put that one over on this side. I'm going to solve this one for y as well. So my equation was 2x plus 3y equals 6. Okay, so again, we've got to move stuff around. So I'm going to move over my 2x by subtracting it to the other side. I'm just moving it over. 3y comes down equals negative 2x plus 6. Divide everything by 3. Okay, so we're doing all that. We're getting y by itself. So now this cancels out. Y equals negative 2/3 x plus 2. So here we go. Okay, now, let me move my little mouse so you can see that better. Those are my two equations, okay? Y equals 1x minus 3 and y equals negative 2/3 x plus 2. Okay, so I'm going to go to my graph. And I'm going to draw this out for you so that you can see it. Okay, so here we go. Here's my graph, right? We have our x-axis here, and we have our y-axis here. So when we graph, we always graph the y-intercept first. So I'm going to go to my first line, okay? My first line starts at negative 3. So we're going to go down 1, 2, negative 3 and put a dot, okay? Then my slope is 1. Well, it's 1 over 1. Rise 1, run 1. So up 1, right 1, up 1, right 1, up 1, right 1. Okay? I'm going to keep graphing. All right. So that's my first line. We can go down 1, left 1, 2 if we need to. And here's my first line. Okay? Line right here. Now we need to graph our second line. If I look at my second line, it starts this time at positive 2. All right, so I go to my y-axis and I'm going to go up 2 on my y-axis. And this time my slope is down 2 to the right 3. It's negative 2/3. Okay, so on my graph, I'm going to go down 1, 2 to the right 1, 2, 3. Ooh, you can see we already intersect. But again, I'll just do 1, 2, a few more dots. 1, 2, 1, 2, 3. Okay, And there is my second line. And this system, meaning these two lines, are intersecting right at this dot right here where they both intersect. They cross each other. Well, the coordinates of that point are the point 1, 2, 3, 0. And so my solution to the system is the point 3, 0. So it has one solution at 3, 0. Okay, so one solution. All right, let's go to another example. Okay, so let's get this erased. And I'm going to erase this, and we're going to look at our second system of equations. Okay, second system of equations. Okay, so we've got the first equation, 3x minus y equals -4. Over here, we have 3x minus y equals 0. We have to solve both for y. So they're pretty similar, okay? We have subtract 3x over to the other side, okay? And then, all right, so then we have negative y equals -3x minus 4. Divide by -1, and everything gets divided by -1. So y equals 3x plus 4. First equation. Subtract 3x in the other one. Subtract 3x in the other one. Okay, to move it over. What's left? Negative y equals -3x plus 0. Divide by -1. Divide by -1. Okay, so what's left? Y equals 3x, and 0 divided by -1 is still 0. Now, do I have to put a plus 0? No, but it helps me with my graphing, so that's no big deal. So then we're going to go and we're going to have to draw another graph. So I'll sketch this out for you so you can see that. All right, so let's get our axes drawn. All right, so I'm going to graph my first line. My first line is the equation 3x plus 4, meaning we start at positive 1, 2, 3, 4, and my slope is 3. So up 1, 2, 3 to the right 1. 1, 2, 3, well, it can't go up anymore, so down 1, 2, 3, left 1. 1, 2, 3, left 1. Okay, there's my equation, graphed as a line. Let's do the next one. This one starts at 0, so we put a dot on 0. We go again up 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. Oh, and down 1, 2, 3 to the left 1. 1, 2, 3 to the left 1. Here we go. There's my second line. Huh. Where do they intersect? They do not intersect. They have the same slope. Lines that have the same slope are parallel lines. We talked about that earlier this year. And so when the lines are parallel and they do not intersect, you have no solution. Okay, so that's our second option. They may not intersect. So parallel lines, no solution. All right, let's look at our third option. So first option, they intersected at one point. Next option, they were parallel, same slope, did not intersect at all. Now, let's look at our third option. Okay, so here we go. Third option, here's my first equation. Y equals 2x minus 3. Well, this is already in slope-intercept form, so we don't have to fix this one. That's the first one we're going to graph. But the second equation, 2y plus 6 equals 4x. That one I have to fix so that y is by itself. Okay, so let's do that. Move your 6 over. This time the 6 has to go to the other side because we want y to stay there. So 2y equals 4x minus 6. Divide everything by 2 so that we get y equals 2x minus 3. There we go. Two equations in slope-intercept form. Let's put those on our graph. Wait, put them on the graph, they're the exact same line. So when I graph them, if they're the exact same line, how many lines am I actually graphing? Just one. So again, when we graph it, we still have to graph. We start at -3, okay? And our slope is 2, so up 1, 2 over 1, up 1, 2 over 1, or down 2, left 1. There's our line. There we go. And it's only one line. It's the same line. It's the same equation, same line. What does that mean? Infinitely many solutions, IMS. Infinitely many solutions. All right, so that is graphing to solve our system of equations. All right, so when you do your practice, that's what you're going to do. Now, if you don't have any graph paper, which I don't think many of you do, I will attach some in the module. You can print that off. Otherwise, just sketch a graph, guys. Do the best you can if you can't print off the graph paper that I post in there. Okay? Hang in there. A couple more lessons, and then we're moving on to our exam review and our exam, so not much time left. All right, thanks, guys.